Okay. This first one, I gave you some prefix abbreviations or prefixes. A, B, C, E. Micro, milli, nano, and centi. And ask you which is the smaller unit. And which one's the smaller unit? Nano? Yes. Micro is 10 to the minus 6 dimension. Milli is 10 to the minus 3 1,000ths. Nano is 10 to the minus 9. And this is 1/100, 10 to the minus 2. Now you need to go back and look at that diagram that I drew, which says, well, we have a standard in the middle, which can be meter, gram, even though it's not the standard, and second. And so you have larger blocks of this standard or fractional. A fractional block of the standard. So make sure you're on top of that. Nano is C choice. The SI unit for length is what, Josh? Standard International Unit for length.
Meter.
And the system of units, we're basing everything on fundamental quantities. Of length, weight, and time. And for the English system, we have foot, pound, and second. And in the metric, sometimes this is an SI, or Standard International System, but there are brethren who say MKS, meter, kilogram, second. They call it the MKS system, like that. Where you may have another system in the metric called a CGS, centimeter, gram, second. But the Standard International refers to the MKS, the meter, kilogram, and the second. When I made out the table up here and put the prefixes, if you go back and look, I capitalized everything that was larger. And I made lowercase at the beginning, like milli would be a lowercase m, but mega would be a capital M. Now, some people insist that that's a very important standard. And other people says they never could find the document that establishes that standard. So some people use it, some people don't. Either way, I'm good with it. Okay. Let's see if I can get over here a little more. All of the following are fundamental quantities except what? Anybody? I got length, weight, time, and is gravity? No. Okay, the only fundamental quantities are those, and are really a description of what you're trying to measure. There are other fundamental quantities dealing with intensity of light, lumens. Actually, there's one is a mass concept known as, of course, we'll cover it, moles. Okay, and sound intensity, decibels, and stuff of that nature. you probably won't see a lot of those. But anyway, gravity is not a fundamental quantity. It's a constant, but it depends on where you are, what reference frame you're in. For how many sig figs does this have? Well, we learned how to count these. If it has a decimal, you count what? Right to left. If it doesn't have, if it has a decimal, left to right. If it doesn't have a decimal, right to left. Everybody remember that? Sorry about that. So as we count through this number, the first non-zero digit we come to is here, and then there are two more after it, and that gives you 3 sig figs. If this is still a little confusing to you, go look at the video online. I have it for significant figures in the measurement section and in the special videos. I think it's significant enough that you need to look at that. One last comment on this issue. Last comment here. Sig figs are created or established to reflect the accuracy of the least accurate instrument in your experimental process. So sig figs are from a practical standpoint. From a theoretical standpoint, you could use as many decimals you want. Today's work is going to have a 4 and 5 digit past the decimal outcome. Fine. It gives you a density, theoretically. But from a practical standpoint, and in consideration of how accurate your experiment is, you have to round everything to whatever the least accurate device is. Please remember that. So sig figs are reflect accuracy of the least accurate measuring device. And one other thing I wanted to share with you on sig figs. When adding and subtracting sig figs involving exponential notations, all of the numbers that you add together, coefficient numbers, need to be in the same power of 10. Everybody got that? I mean, you understand that? Okay, here's the curveball. Watch this one. Now, there it is. In this, you want to add those two together. Question. Who is converted to what? Here you got an exponential notation over here. This one doesn't have an exponential notation listed in context of it. Do you convert the 154.25 to a negative, or do you convert the negative exponent to the 0.25 version? Which one's correct? A or B? Anybody want to try to stab at it? Which one? See, you got one that doesn't have an exponent, and you got another one with an exponential notation. The rule is they have, before you can add them together, you have to convert them to exponential notations, right? That you understand. The question is, which one do you use? Anybody? And why?
Are they both correct? Are they both correct?
Please speak up.
Are they both correct?
Oh yeah, they're both correct. It doesn't matter about the data, and they will add up to give you equivalent numbers. It's the expression, how they're expressed.
In the first.
Okay. The rule is, if you have several exponential notations in an adding or subtracting problem, you convert to the number having the smaller exponential notation. Convert the numbers to match the exponent with the smaller, okay, numerical value, absolute numerical value, absolute numerical value. For example, this would not be correct because this actually is 10 to the 0, the smaller absolute value. And so to get this to a 0, we'd have to move back to the left, you add back. Okay? You convert your numbers to the least, smallest absolute value digit of the exponents. That's not in many textbooks, but it occurred to me while I was working on some stuff this weekend. Finally, which of the following is considered a complex unit? Now, this is kind of a slide over into today's work, and I had it on the video if you understand it. Units that consist of different, let's put it this way, fundamental quantities are complex units. Today we'll talk about 3 types of conversions. I classify them like that for academic instructional reasons. Conversion's a conversion. You just got to know how to deal with it. A, what we call a simple conversion, which is unit to unit, like grams to kilograms, or something like that. You're in the same system. Or a exponential conversion, or multiple conversion, some people call it. That's like square feet to square meters, if you were converting, something like that. And complex conversions, which are combinations of the fundamental units. What did I have in here? Pounds per gallon. Well, the denominator unit is a volume, and the numerator unit is a weight. You can't convert volumes into lengths or weights, or okay, that kind of thing. So these would boil down to 2 different types of units. Another way to do this, based on the pounds per cubic foot, I should say. Cubic feet. See, pounds can't convert into feet, and feet can't convert into pounds. So you have to leave them in that context as a complex unit. So this one is C choice for the pounds per gallon answer.